Hey, what is up, y'all? We are making a game of Go. I asked you of the last video to practice making the Whitestone class. If you if you were particularly lazy, you probably just copy and pasted and then changed all the names of Blackstone to Whitestone, which you could actually do with the replace command. But hopefully you didn't do that. Hopefully you actually tried to code it a little bit and think about it. There's some other things we could do. You may have thought, Wilshire does not like me to be very repetitive, and this code here gets pretty repetitive. And so we could have done something kind of interesting. We could have done a while loop or a for loop where when we're on loop number 0, we do this code because really this is the only unique part of the code, and then we could change it to this code and still keep all of this code here in the loop. Would have cut down our code, well, quite a bit in size, but I think it was more understandable that way. It was only 4 of them, so I thought it was okay. Just something to think about. Today we're going to make our board, so I'm excited to do that. Let's get going on it. We are ready to make the play, and what I'm going to call it is space. Okay, so I'm going to say we're going to call this the space class. So we're going to subclass actor, and we'll make something called space. And the most of our space, when we do a 19 by 19 board, there's going to be like just that outer edge is going to be something unique. The interior is all going to be the same. So let's make that our default, and we'll change the other ones. So cross. Okay, that's going to be our default shape. So we do need a constructor again. The constructor public space. Well, I don't. We actually don't need much work here, because this is going to be the constructor for when we want that default image, right? That cross there, that's the interior. But we do need to make sure that we size it correctly. Remember, these spaces need to get smaller as the game size gets bigger. So let's get a Greenfoot image. So I'm going to say Greenfoot image, and I'll just give it, I can give it any variable I want. I like img, get image. So for the default space, it's going to be that cross symbol, and I'm going to say image.scale, and I'm going to scale it based on the size of our cell. So I'm going to say go.cell size. Remember that constant that we made in the Go class right there? Oops, a little hard to read. Kind of glitchy. Well, I'll go to the documentation and see what that likes that. Sometimes it uses a lot of my memory up when I try and videotape while I'm coding in Greenfoot. But there it is, that cell size that we made. That's what we want to use. So I'm going to use that here. And I actually want to use the entire cell. I don't want any gaps. So I'm just going to say, last time we did this, I think we multiplied it by like 65 over 100 or something like that. I'm just going to use the full cell. Okay. So that's going to take that image and scale it. Then we just needed a reference to its image for this brief moment. That's why I didn't make it a instance variable, just a temporary variable. All right, the next one I want to make is one where we actually can change the image. So I'll make a constructor that takes in a parameter, and I'm going to take it. Let's take it in as just a string. We could take in a Greenfoot image, but I think the string is going to be fine. And I'll just call it img name. So the first step that I'm going to have to do is to create a Greenfoot image with that. So I say Greenfoot image, that's the name of my object. img will be the variable name. I can use it again because this one's gone. Remember, it only existed in that curly brace. And we make an object by saying new Greenfoot image. And the Greenfoot image takes in an image name. So I'll say image name. There we go. So whatever file name we give it here will now go there, and that'll be loaded into an actual image. Once I've got that image, I do want to scale it. So I'll go ahead and do that now. but I also need to set the image of this actor to that. So there is a method in the actor class called setImage, and I'll go ahead and do that. And we're setting the image of this object, so it's just setImage. Okay, how's that look? Pretty good? All right, then let's continue. We've got the ability to make different ones. We need to look and see. Let me check my class diagrams I got over here and make sure that I got everything I need. I don't. I think we just need. Oh, we just need one method. We need the act method now. So what's the act method going to be like for a space? Well, the way we're going to play the game is we're going to click on different spaces with our mouse. So when a user clicks on a specific space, that means they want to put a stone there. So that's the way we're going to do this. And we need to bring up, once again, the Greenfoot documentation. So let's go to the Greenfoot class documentation. You could also bring up the Java library documents, but we just need these for now. And we are going to be looking at mouse info. No, I don't want mouse info, actually, to tell you the truth. I don't want that at all. It's probably just an actor. Never mind. Let's see here. Where is it? What is it? No, that's not it either. It's in Greenfoot. That's it. Mouse info is something cool, and we can use it to do a nice extension in this project. But here's what I want. Greenfoot.mouseclick. Greenfoot is also, that's where all those static methods are. We used it when we got keyboard input. Greenfoot.mouseclicked. That's what I want. That is true if the mouse has been clicked and released on an object. And notice it's of type java.lang.object. That everything's an object, so it's the most generic thing that you can have, which is makes it very useful. All right, so we're going to say if greenfoot.mouseClicked, what? We need to give it an object that was to ask if it was clicked on. Well, we're going to be, remember the act method is going to be called on every single actor in our world, and our space is an actor. And we're checking if we are clicked on this space. Get it? So this myself. If the greenfoot.mouse clicked on this cell, then what do we need to do? We need to put a stone there. So we need to make a new stone. Well, which kind? Well, we can say if, now we got to figure out whose turn it is, right? So how are we going to do that? Well, we need to get the world that this stone, this space belongs to. So we'll say, let's do that first. We'll say, go is the name of it, the object. So I'm going to say go, just go, equals get world of type go.class. All right, that's a little bit of a confusing method. We have seen it before. Let's go back to the, I've already got up here. Let's go back to the actor class and look at the notes for that. So we have the ability to get the world, and that just gives us the generic world like adding and things like that. But get world of type allows us to add objects and all that, but it will specifically give us the world that we have subclassed. So it allows us to get access to our subclass. So when I say get world of type go class, it's actually going to give me all the methods of go that we have written, in addition to all of the, and this is still being weird, all of the methods that come with world. So we're going to be able to use all of those as well. Well, there it goes. It's starting to load. It's fighting. All right. Apparently I misspelled window. Okay. So it's going to allow me to call is black turn and change turn. That's what I want. So I can't just get an instance of the world. I need to get an instance of the go world. So I've got that, and I just called it lowercase go. Actually, let's call it game because I hate saying go like 3 times. All right. So if game dot, and I've already forgotten what it's called. It's called is black turn. Is black turn. Then we need to make an instance of Blackstone. So I can say Blackstone stone equals new Blackstone, and I need to add it to the world. So I'll say game.addObject. Remember, game is a world, so it has that method. And when we add an object, I never remembered, is it object XY or XY object? Well, okay. Don't have to remember, right? I've got, because I've got the ability to load it up. It's bad at me. It doesn't want to do that. I'll do it over here. It's waiting for me to finish that line of code before it lets me open up another class. So let's see here. Add object actor int x int y. Actor xy. Got it. So the actor I'm adding is the stone. The x that I'm adding it, where am I going to add it? I'm going to add it on this space, right? Get x, get y. So the space set of this tile. Okay. Else, what are we going to do? We'll make a white stone. You may notice I'm using the variable name stone again. That's fine. I declared it inside an if statement. It was inside those curly braces, so it's gone by the time I get over here. It's not a problem at all. And there we go. And what we need to do is we have just played a stone. So you know what we need to do? We need to change turns. So I'll say game.change. Is it change turns? Or change turn? I don't know. Change turn. Okay. There we go. Okay, so now we can click on the stone. Oh, it needs to be white stone. There we go. Now we can click on the tile and the space, and it will actually put a stone on there, which is super cool. All right, let's go ahead and go back to Go. I think we're ready to go back to Go now. And this is probably the second most difficult method to write. Not anywhere near as difficult as the get liberty, but we need to set up our board. Okay, so let's do that. So after we have when we make a game, we have to create all this stuff. We want to go ahead and make it to where the board is actually set up and ready to go. So let's do that. Let's just say, we'll call it make board. How's that sound? And let's write that method. Public void make board. Okay, I think I somewhere here have an example of one running. So this here is one cell, this whole area here. And then this next to it is another cell. They actually divide right here, like halfway through what you would think of normally. If we were doing like a checkers game, I think we would get away with making our cell just the entire box. But for us, we're interested in that points of intersection. So it's there, 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 and there. And there's 9 of them, right? Now the upper left, upper right, bottom right, and lower left are these corner pieces. So we want to make sure that we use the right ones. Let's take a look at the images that we have for this. So here are my images from my here's my project and my images folder. I got bottom left, I got upper left, upper right, bottom right. Let's just do those right by hand, without a loop or anything like that, because there's only going to be 4 of them, okay? And we know where they're going to go. So we're going to say, what are they called? They're called the space, right? So space, I'm going to call it up left equals new space. Now remember, our space class had 2 constructors. The default one is the one in the interior. We need to be the one that we give it a name. And the name of that object was upper left, and these are .pngs. So we'll give it that full name. So quote, because it's a string, upper left .png. I think that's right. If I look at, let's see here. I could go to view here, and we could look at the details. Yeah, they are PNG files. Well, except for that background I'm using. But so upper left .png. Right, and then I'll go back to. I like being able to small icons. Ooh, tiles. Ooh, that's very helpful. I can see the file type and everything. I like that. All right. All right, now let's add it. So we already are in our world class. So I don't have to get world. I'll just say add object. And it's object, it's actor, X, Y. Upper left is in X position 0. Y position 0. That one's easy. Space, now let's do another one. Space, up right, upper right .png. And add object. Now, where's that going to go? Well, that's going to go on X coordinate equal to the size of our board minus 1. Because remember, our game size is 9. There would be only 8. If it's 19, the last one would be 18. There's going to be 9 of them, but they start at 0, then go up to 8. So that's game size. Notice I don't have to say. Earlier we had to say go dot game size, but I'm in the class, so I can just say game size. I could actually put that as well, and it would still work. So game size minus 1, we said, right? And then the y is still 0. All right, space, bottom right. The bottom right is going to be a space, and I think it's called bottom right. I'm pretty sure. I'll double check. The picture that is yeah, and we'll add that object, and it's bottom right, game size minus 1, because we're on the right hand side, but we're also on the bottom, so we're also going to say game size minus 1 for the y's as well. Okay, and then I need another one of space, so I'll say bottom left. Okay, and I'll add the object, bottom left, and that's going to be at x coordinate 0, but the y coordinate needs to be at our game size minus 1. All right, that's going to make our positions in several different places, the upper left, upper right, bottom left. Now let's make the tiles that go in between them. So I'm going to use a for loop for that. I want to loop, and let me pull up my example right now. I want to loop across the top. So I'm going to loop from an x. I'm going to be on y coordinate 0, but my x coordinate needs to be 1, 2, 3, 4, 5, 6, 7. So let's do that. So for int I equals 1, I less than, well, remember the game size could change. So I'm going to say game, I can't put a number. I'd say game size. Well, I'm going to say game size minus 1 because I'm saying less than. If I say less than or equal to, I need to say game size minus 2. Remember, game size is actually not a cell number that we're going to use because our cell numbers go from 0 up to game size minus 1. But we've already put one there when we put that upper right-hand corner. So I could say I less than or equal game size minus 2, or just say I less than, which I think is fine. And then I plus plus. That's my for loop. All right. Next, we're going to add them. So I'm going to say space S equals new space. What kind of space is this? Well, if you look at your pictures, it is the not bottom edge, top edge is what we're calling it. So top edge.png. And I'm going to say add object. What object? I'm adding S. Where am I adding it? The X coordinate is going to be I. The Y coordinate is going to be 0. Maybe it would have made more sense if I had used for int X equals 1. X less than game size. I don't know. What do you think? But I'm just using I. All right, we're going to do another one. We're going to say for int I equals 1, I less than game size minus 1, I plus plus. This time I'm only doing the right edge. So I'll say space S equals new space right edge, I think is what it's called. I will double check. Just give me 1 second. Yeah. And we're adding all the way down the right hand side. So when I add the object, I'm adding S, and it's going to always be at the far right side, which is game size minus 1 for the X, and the Y coordinate is going to be just simply I, because it's going to range from 1, 2, 3, all the way down to 1 less than the game size minus 1. All right, we have another one to do. For int I equals 1, I less than game size minus 1, I plus plus. S space S equals new space bottom edge. All right. Add object S game size minus 1 is going to be we're doing the bottom edge, so that X needs to be my I value, because X is going to, when I equals 1, it'll be there, then 2, then 3, then 4, then 5. So that's what we're doing. So I, comma, I'm on that bottom side, so I'm going to say game size minus 1. All right, then for int I equals 1, I less than game size minus 1, I plus plus. Let's do another one. What will it be? What will it be? Space S equals new space left edge .png. Add object. Oh, I should not have capitalized that. There we go. S. We're going to be on that left edge where the X value is always 0, but the Y values are going to go here, 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 here. So I'm going to use I for the Y values. Okay, let's compile. Does this thing compile? It does. Let's take a look at our, well, that's not us. that's my example one. Sorry. Let me pull up our code. And all right, look at that. We've got it. It's just we got to fill in the inside now. That's pretty exciting, right? Okay, so for the inside, what I'm going to do is I'm going to loop all the way across like a typewriter on each one of these, and I'm going to loop from 1 to game size minus 2 on the X's, and from 1 to game size, oh, not 1. Yes, 1 game size minus 1 to the Y's. All right, let's do it. So here's when we fill in the interior. 4, and I'll use X and Y this time. Int X equals 1, X less than game size minus 1 again, X plus plus. Now I'm going to do another loop. For int Y equals 1, Y less than game size minus 1, Y plus plus. So we are now filling in all the interior, right? And let's make a space. S equals new space. And that's it. Remember, that's our default image, so we don't have to do that one. Add object S at X comma Y from our loop. Let's compile. Huzzah! Let's run it. There's stones appearing. But now, the real test. Can we capture? Let me put some white stones off there. I'm going to capture white. Okay. Moment of truth. Boom! Okay, so that's pretty fun. You can play this game right now. You just got to keep score on a piece of paper how many stones you captured. In our next video, we're going to fix that by putting that information right here, including information about whose turn it is. So we know whose turn it is and how many of each stone's been captured. In the next video, which is going to be our last video working on this together, and then it's all about you making it even better. So I'll see you then.